Hello, everyone. Thank you so much for joining me today. I'm going to highlight one of our newest features in exSILentia called Project Merge. Project Merge allows you to take two separate exSILentia files and combine them into a single file. This is especially helpful for people who have done their project work over multiple exSILentia files and find later on they want to combine that data. This will help them to benefit from the full integration that we have within exSILentia between the modules. And so before I get into the details of how to do this merge function, I should introduce myself. My name is Kate Hildenbrandt. I am a product manager at Exida for our exSILentia software. I also provide training and customer support. So if you have any questions for me on any of our tools, you can use my email address that's here at the bottom of the slide. Feel free to reach out and ask me any questions you might have on this topic or any topic regarding our software. So the objective of Project Merge again is to take two separate exSILentia files and combine them into a single file. And to understand why you might do this, you have to understand the integration that we have within exSILentia between our modules. The idea is that within exSILentia, you can document your process hazard analysis. You would be able to take a look at any high risk scenarios you have with your system, document the cause, the consequence, and any safeguards you have to bring your process back to the safe state if an event were to occur. For high risk scenarios, you can automatically move that data over into the LOPA. So, in that case, your causes would become initiating events, and your safeguards would become potential IPLs for your LOPA analysis. This makes it easy to get started with the LOPA task of defining the initiating event frequency, the probability of failure for your independent protection layers, as well as any conditional modifiers or enabling conditions. And this helps to determine if you've reached your tolerable frequency for the hazard. In cases where you have safeguards that are safety instrumented functions, you would be able to proceed to the SIL selection tool to determine your target SIL or target risk reduction factor for your safety instrumented functions. Once you have your integrity requirements defined, you can then document all other requirements in the safety requirements specification module. And so within exSILentia, you can have your entire analysis complete and documented within the tool before you start with your SIL verification. In Silver, you would be able to document your equipment selections, you would be able to model your SIF structure and specify your testing strategy for proof testing your SIF equipment. The results from Silver will be your achieved SIL and achieved risk reduction factor. You would be able to use the lifecycle cost estimator to determine how to optimize costs as well as your optimizing safety. So, in cases where you don't reach your target SIL right away, you would be able to determine if you should add redundancy or perhaps do more frequent proof testing. With the lifecycle cost estimator, you can determine how that affects the cost of implementing your SIF. Then you can go into the design SRS and document requirements for implementation now that you've determined your SIF structure, your final equipment selection, and so on and so forth. This is going to help to communicate any implementation requirements for the safety instrumented system. We have a proof test generator that allows you to specify the proof test procedure that you're going to use in the field when your safety instrumented system is online. This helps to ensure that the proof test coverage that you're using in Silver is matching the proof test effectiveness of the procedure that you ultimately use in the field. And then you can use our SILStat tool to record data during the life of the safety instrumented system for any time you have failures, anytime you have a demand on the system, and to keep up with that proof testing. Now, this all works nicely if you do it in that order. But the idea behind Project Merge is that some of our users might start with the SIL verification. They might design their full safety instrumented system in one file. And then they may adopt our PHA and LOPA tools, perhaps at a revalidation, and start with a new file to do the PHA LOPA work. And so Project Merge is meant to act as a bridge to fill that gap between analysis and design and make sure that if you'd like to, you can combine that data into a single file to benefit from the full traceability that the integration between the modules allows for. And so we've created a merge wizard that allows you to choose two files with separate scopes and create a resulting file where you can tell that the safeguard from one file is the same as the SIF in the second file. When we created this, we wanted to make sure that we weren't affecting your original files at all. We know that the work that you put into documenting your analysis and design is time consuming and takes a lot of effort. So we don't want to affect your original exSILentia files. Even if you have copies saved, we want to make sure that there's no risk in doing this merge feature within exSILentia. And so what we're really doing is we're allowing you to specify your two files and we're generating an entirely new file that combines their data. For the sake of simplicity, for the rest of the presentation, I'm going to call these file A and file B as the files that you're combining. And the file that we generate with the merge wizard we'll call file C. And again, for now, with the merge function, this really works best if these files have separate scopes. And so we'll talk about exactly how we can specify the files and specify the scope in each file in order to proceed with the merge. First, you would want to launch your application. And you're going to proceed as if you're creating a brand new exSILentia file. And so this should look familiar to any of our exSILentia users. You're going to first open the app and you'll see this view. We have our normal options for creating a new file. We've always had options where you can start your new file with the exida defaults or start with a completely empty project. Our custom option allows you to pull just the project and risk config from an existing project. And now our merge feature allows you to combine two files into one. When you select this button, it will launch the merge wizard, which looks like this. The first thing you'll do with the merge wizard is select your files. And so to select your file A, you simply select this button. It'll open up a browser that allows you to browse to a .exp file. This feature works only with exSILentia files, and in particular, the ones that are of type functional safety. And so it'll limit you to that. It will allow you to select your file. You can do the same with file B. And once you've chosen your files, it'll show some high level project information right off the bat. So you'll see the path to your file. You'll see the ID and the name that you gave your project, as well as any additional information, the company that defined the project, the revision, and any description of the project. You'll see the same for file B. These fields do not allow you to adjust this information here, but it will help you to remember which files you've specified as you move on to specify the scope of each file. Now, as I mentioned before, we really want these project files to have separate scopes in order to properly combine the data. And so there's only a few options we have in that case. And this slide helps to reflect exactly what those options are. So within the merge wizard, you could define a file that simply has your PHA data in it. That would mean that your other file would pull from LOPA, SIL selection SRS, Silver, design SRS, cost, and proof test generator. You might have a situation where your first file has your PHA and LOPA. And in that case, you've done your SIL selection, SRS, Silver, and so on within your second file. For option 3, perhaps you've done PHA, LOPA, and SIL selection in your first file, but you've documented your SRS with your safety requirements for the SIF before doing your SIF design, your design SRS, and your procedure specification in the second file. And the final option is really where you have your complete analysis in the first file with PHA, LOPA, Select, and SRS documented. And in your second file, you did your complete design with Silver, Design SRS, cost, and proof test procedure specification. And so when you select the phases attributed to each file, it will limit you to these options so that you can properly sort of bring the project data together and benefit from that full lifecycle integration. You'll notice that Silver, Design SRS, Cost, and Proof Test Generation is always in the same file. The Design SRS, the Cost module, and the Proof Test Generator really depend on the work that you've done in Silver. And so it doesn't really make sense to split those up. But depending on where your break is, otherwise, we do have these options to allow you to combine that data. You also see additional project options listed under the phases. And these include specifying which project you want to pull your project and risk configuration from, as well as your cyber checklist and your IEC 61511 checklist. The checklists really stand on their own. So if you've done that work in one of the projects and you want that in your file C, you would be able to simply pull that from either project. The project and risk configuration depends on your scope. So if you have PHA and LOPA in one file, you most likely want to pull your project and risk configuration from that file. Remember that PHA, LOPA, and Select are heavily affected by the risk configuration. And so it could be risky to merge two files that have different risk configurations. That could, in fact, impact your entire analysis. And so, one thing we want to ensure before you move into merging the projects together is that your risk configuration matches in both files. Ideally, they match exactly. Because again, these configurations impact the work that you've done in PHA, LOPA, and Select heavily. And so your analysis essentially changes if you change your risk configuration. It is required that file A and file B have the same number of severity levels and likelihood levels. And so if this isn't true, it will not allow you to proceed with the merge. However, we really recommend a thorough review of the entire configuration and would recommend that you have them match before proceeding with the merge. So once you've selected your file A, you can go on to select which phases you'd like to pull from that file A. So you can say, in this example, we're saying PHA, LOPA, SIL selection, and SRS data are pulled from file A. We're also saying that the project and risk configuration and both checklists are being pulled from file A. The wizard will automatically know that that means that Silver, Design SRS, Costs, and Proof Test Generation are pulled from file B. Because again, with merge right now, we're assuming that you have split scopes in these projects. And so as soon as you choose PHA as being pulled from file A, it will automatically assume that your Silver is being. Finally, we have some merge preference options here. The first option says match items on start. This will match identical items from file A and file B to be a single item in file C. This is an option I think you'll understand a little bit better as we work through the workflow, so I'm going to come back to this. The second one says open on completion. This means that when you're done with all of the merge selections and you decide to generate your file C, it automatically has exSILentia open it and you can review it immediately. The alternative is to simply save it and come back to it later. You can select this option later in the workflow, so you'll be able to decide later on if you would like open on completion. But if you're sure of it here, you can definitely select it before you hit begin merge. So once all of your phases are selected, you have your options and preferences selected, you can hit this large begin merge button and it will allow you to proceed through the workflow. The first thing we're going to talk about is how to match items in project and risk configuration. So when you proceed, you're going to see this view, which shows you 4 tabs. We have a tab for project configuration, risk configuration, the library, and your output, which allows you to define your project info for your file C. But we'll start with project configuration. And what you'll see here is a number of categories where we're going to look at the items in file A and file B and determine how to match them up so that they're a single item in file C. The categories we're looking at are plant types, nodes, safeguard categories, recommendation categories, statuses, and priorities, reference types, team roles, and team members. And the reason you want to make sure that you go through this in detail is that you don't want any repeats in file C that should actually be the same item. So, for instance, in team members, you don't want to list the same person twice. You want to make sure that everywhere they're assigned, no matter which module, it's the same team member. The same goes for all of these categories. So as you move through the project configuration, you'll see that each category has a number here of unmatched items for each file. So for plant types, you see 10 unmatched items for file A and 10 unmatched items for file B. So it's basically letting you know how many items you have to review. If you proceed with plant types, the next column shows you each plant type in each file. So you see the list of plant types in file A and the list of plant types in file B. Lucky for us in this example, they look to be identical. That's because we're using the exida defaults and also because we reviewed it to make sure that they match before merging. So that makes this example pretty easy. To match a plant type in each file to make sure it's one entry in file C, you simply select it in the table for file A, select its match in the table for file B, and then you select this button that is the merge button. And this will merge the items that you've selected. You'll see then that it moves over to the final column here in the merge wizard to show the entry in file A that's matched with the entry in file B to be one item in file C. So we have one plant type in file C called refinery instead of, if they were unmatched, two. And we could proceed to match all of these items. Let's say while we're matching items, we make a mistake. In that case, you would select the row that the mistake is made in. Now, in this case, we're going to do it with refinery, which is correct, but let's assume it's incorrect. We can select the row and select this button, which is the unmerge button. And that will simply move it back over to the middle column where it returns to its file A and file B list. We can figure out how to handle that. Now, again, for this example, we have 10 plant types here that match perfectly. Isn't there a faster way to do this than to select each one and merge them individually? That's where our third option comes in, where we can select this button for auto match. And this is going to match identical items and move them all over into the third column. When we say identical, we mean identical. That means no typos, means no extra spaces, nothing. We don't want to make any assumptions that things are identical when they're not. And so we select the auto match option and everything moves over because they are all perfectly identical. So we have our whole list of plant types merged. We're determining exactly how they'll look in file C, which is just to have a list and hopefully no duplicates. And we're good to go. So that's a bit of a time saver. Finally, let's say we're very unhappy with the work we've done. We want to reset everything. The fourth button will allow us to do that. So you select this button and it returns everything to its original state. Now you can see how powerful that auto match feature is, especially in cases where everything is clearly identical like this. It's a bit of a time saver. So if we remember this view that we started with in our merge preferences, we had this option to match items on start. And this will match items automatically that are identical for all categories across the merge. And so for project configuration, for risk configuration, and for libraries, we'll automatically match everything that's identical. And that should be a bit of a time saver for you if you run into what we just ran into with plant types. That doesn't mean you shouldn't review it. So you want to go in and look through everything that was automatically matched and make sure that that's what you would like to match together. But if it's a no-brainer and they're identical, then this feature would be nice to select as you go through the merge. It is going to save you quite a bit of time. So if we return to the project configuration, you now see we auto matched everything. Everything that's identical was matched at once. And on this side, you see that we have 0 unmatched items for file A and 0 unmatched items for file B. So this is what we want to see for project configuration and risk configuration. We really don't want any individual items hanging about. And so if you hit auto match for those, it's not going to pull over anything into this column that doesn't have a match. We want to make sure each thing has a match. If you find halfway through the merge that you maybe made a mistake and you want to go back to the source file to adjust before merging, you can do that. You can simply X out of this, you can adjust the source files and proceed with another merge. Remember that none of this is going to affect file A and file B. So even if you generate a file C and you review it and you find that some mistakes were made, you can always start the process over again. With that, we can move on to risk configuration. And here we see the severity categories, the severity levels, the likelihood categories, the likelihood levels, and the risk levels. And again, we're going to go through each. You can see the number of unmatched items. You can see each category we're going through, and you can see the list of items from each file. In this case, you want to make sure there's a match again for every item. So this would be a good scenario to again hit that auto match. We have business, environment, and safety as the severity categories in both files. That's what we want to see when we're a project merge because remember, we highly recommend that they're basically identical before merging. If they're not, it could have some serious impact on your analysis and your resulting file C. It was required to have the same number of severity levels and likelihood levels to start. That was a requirement. You would not have been able to proceed without it. But we really don't want to change the severity categories. We don't want to match business with environment. That would change our entire analysis. And so we want to be careful when we do this to go through these and make sure that you're essentially matching identical. Again, if you find in here that there is something that is different between the risk configurations, you can always X out, fix it in the origin files, and start again. But here you're going to walk through the severity categories, levels, likelihood categories, levels, and the risk levels, and make sure that they all have a match and that those matches make sense for file C. Finally, we're going to talk about libraries. And libraries work a little bit differently than the project and the risk configuration. So we'll talk about how. Here we see a list of the libraries that we need to address given that the projects have separate scopes. And that includes the units, causes, our SIF safeguards, and our non-SIF safeguards, safeguard groups, recommendations, references, hazard scenarios, enabling conditions and conditional modifiers, our risk modifiers from our SIL selection tool, any of the tags defined in silver, our proven and use justifications, our input and output parameters, labels, and proof tests. For libraries, not every item requires a match. So it's possible for you to have a different number of each of these in file A and file B. And so the way that we merge and match is you can merge identical items or non-identical items. You can see here I have a unit defined in file A that's the same as the unit in file B, but I named it differently. So I can manually match those. But you might also have items that have no match. And in that case, you can use that merge button to move them over so they're included in file C, but they don't have a corresponding match from the other file. The caution icon is going to alert you that items remain in the library and they're not yet merged into file C. So that means that you're leaving them behind and they won't be included. So for the libraries, your merge button, your undo button, and your reset button work exactly the way that they did in your project config and your risk config. But your auto match button is going to match the items with identical names and automatically move over any items without a match so that they're automatically merged individually into file C. So, what does that mean? For the library that we're in, we're looking at safeguards that are CIFs. We have an overspeed CIF, a high vibration CIF, and a level control CIF in file A. We have an overspeed CIF and a high vibration CIF in file B. So when I select the auto match button, what's it going to do? Luckily, the names are identical, which is lucky for us. The overspeed CIF should match with the overspeed CIF and the high vibration with the high vibration. The level control is going to automatically move over with no match. And so I'll select the auto match button, and this is what you'll see. You'll see that overspeed matched, high vibration matched, and the level control is included in file C with no match from file B. And that's okay. We want to make sure to include it if that's your choice. Um, without a match. But for these, what we want to avoid is having duplicates. We don't want two overspeed CIFs or two high vibration CIFs in file C. So we've matched them. So that gives you an idea of how the library operates a little bit differently than the risk and project configuration. You'll see in this entry, there's no more caution sign because everything has been moved over. The caution sign means something's left in these columns. And so you can make sure that so you can see how the libraries work a little bit differently than the project and risk configuration with these unmatched items. Another thing I want to draw attention to is that the CIF safeguards have additional functionality. You notice another icon here showing you that you can make more selections. If I select the overspeed CIF, you can see in this window, we see the integrity requirements from file A and file B. And you can see that they're different. And this allows you to choose which file you would like to draw these integrity requirements from. By default, it's going to have the one selected that you said the SRS should be pulled from because within exSILentia, the SRS is really where we're choosing the final integrity requirements. You might ask why these would be different. And the truth is that if you're merging two files, one with analysis and one with design, you can have two different sets of integrity requirements that might not fully match. Why is that? Well, if one of your files has PHA, LOPA, and SIL selection, you might have a detailed integrity requirement with a required RRF and a required SIL that's based off of your LOPA. You might also have it based off of risk matrix or risk graph. In the file where you did SIL verification, you might have simply directly entered your integrity requirements. And here you can see that the required RRF is a little more conservative in file B, where the SIL verification was done. Perhaps they rounded up. And so for true integration between the modules, in this case, you might want to choose file A because it has that calculation that was done in the LOPA. It's really up to you, but this function allows you to choose which using these buttons here, and then you can see which integrity requirements will move over into file C. So again, that's just additional functionality for the SIF safeguards. Every other library here is going to show you the library details, but has no additional selections to worry about. And again, just so you know, by default, it will show what the SRS is being drawn from, which file it's being drawn from. And so if you don't want to take a look at this, simply assume that it'll pull the integrity requirements from the file that includes the SRS. The other thing I want to say is we've talked about the fact that file A and file B are supposed to have separate scopes. But let's say you choose to merge two files that both have SIFs and silver. In that case, you really want to make sure that when you generate your file C, you review how your groups have been reused and if it's correct. So, anybody who uses Silver knows that we have the ability to indicate that a group within a SIF is the same physical device. So, if multiple SIFs are using the same physical device, the tool can know that. And it builds the logic solver by attributing input output channels to a certain module, and it will know to reuse that group. If you're merging your file using this tool and you have SIFs modeled in silver in both files, you want to make sure to review that. It's kind of outside the scope of what this tool is supposed to do, but it is possible. So we want to make sure you're reviewing that file C and that your SIFs are modeled correctly. So then you can go through your whole list of items for your library and you want to make sure that you have 0 unmatched items. Here, unmatched really means unmerged. So if there are any items left in the middle here and not included in file C, you'll see an icon there. It'll show you. But in general, you might see cases such as this. You see our proof tests have only entries in file B that you're moving over to file C because that's where the seal verification was done. That's where your proof tests were specified. And so that's what you're moving over into file C. You might see a lot of that as you move through the library. What we're looking for is to make sure that nothing is left behind in the middle if you want it included in file C. And so once you're done with each of those categories, you can move on to the output tab. And the output tab is simple. You're just naming your file C. And so you can go on to give your file C an ID, a name. You can fill in the company, revision, or a detailed description. Again, this isn't going to overwrite anything in A or B. So this is just as if you're defining a whole new file. We have this option again to open on completion. So if on the front view you weren't able to select this, maybe you didn't know what it meant, you can now select it to make sure that when you initiate the merge, it will open up your exSILentia file and allow you to review it right away. And so here we can give our file C an ID, a name, and any details. We can select the open on completion, and we can then select the merge project. You see that it'll be grayed out before you give it an ID and a name because those fields are mandatory. Once those are filled out, you will be able to proceed with the merge. You'll see on this side, there is a full merge log that is telling you exactly what actions were taken in the merge. It will let you know that the file is saved. And if you select it open on completion, it will open up that file. And so once the file is open, we highly suggest that you review it. Obviously, this tool is meant to make it easy to combine data into a single file, but we want to make sure that there hasn't been anything that was merged incorrectly and change something that was safety critical. And so, for instance, We talked a lot about making sure your risk configuration was identical going in. You want to make sure that your selections in the PHA reflect that and that your severity categories, severity levels, likelihood levels, and risk levels are all consistent with the origin files. And so you want to go through and review. When it comes to silver, again, you want to just make sure that the SIFs are modeled the same, that the reuse in your original file is reflected here in file C. That's an important feature within silver that you want to make sure is configured correctly. And so it's worth a review of the silver verification module to make sure that everything looks correct and is identical to the original file that included your SIFs that were modeled. And then, of course, you want to look through the library. When we were merging, we had 3 CIF safeguards in one file and 2 in the other. We could have easily come into file C with 5 CIF safeguards, but we merged and matched 2 of them, and we moved the other one over without a match. So you can see here in the library that it merged correctly. We have 1 overspeed CIF instead of 2, 1 high vibration CIF instead of 2, and a single level control from a single file. And so a review of the library is also important to make sure everything merged as expected. So that wraps up our overview of the project merge tool. As you begin to work with it, let us know if you encounter any challenges. We try to make it easy enough to use on your own, but feel free to reach out if you have any questions or need any clarification on how it's working. Likewise, if you can think of anything that might make it easier, please let us know. We welcome your feedback. Usually, if you have something that you feel would make it easier, then you're not alone, and implementing that might be a great idea. As always, feel free to reach out to me with any questions. And thank you again for joining me today. Take care. Bye.